All right, today we're going to look at some examples of solving rational equations. A rational expression is a ratio of two polynomials. It's just like a fraction, but with polynomials. And there's two examples there. We're going to go through 3 examples, and I'll show you how to solve them. Just as a reminder, if we're dealing with a quadratic equation, we can use all of our strategies from Unit 4, like graphing, factoring, using the quadratic formula, or completing the square. We have a lot of strategies for those quadratic equations, so we're going to try to apply them when we can. Let's look at the first example together. We've got x minus 1 divided by 15 equals 2/5. This is a rational expression because it has fractions. We've got a polynomial on top being divided by 15. When you see something like this, and we know we want to get x alone when we're solving for x, we need to get rid of the denominator in this case, because if x is being divided by 15, or if x minus 1 is being divided by 15, we want to cancel that out by doing the inverse. And the inverse of dividing by 15 is to multiply by 15. Let's just go ahead, I'll write it again over here, and then we can start doing the work. I'm going to draw my line to keep my equation balanced and make sure I do the same thing on both sides, so that when I multiply the left-hand side by 15, I'm going to multiply by my right-hand side by 15 to keep them balanced. The 15s are going to cancel, and the numerator comes down by itself. 2 times 15 is 30, and 30 divided by 5 is just 6. So I'm going to simplify that and write it again. Now we have a linear equation. We can solve this by just adding 1 to both sides. And we're left with the x all by itself. That's what we wanted. And x equals 7 is our solution. It's always a good idea to plug it back in. I can do it in my head. I know 7 minus 1 is 6. 6 over 15 is the same as 2/5. It's just a reduced fraction. So I can confirm that that works. Let's look at another one. Here we do have a quadratic expression on top, so we are dealing with some quadratic polynomials, and we're going to be able to use our strategies from the quadratic unit. Let me write out the equation again, and then we'll start solving. This one is similar to the other one where we have something in the denominator that is preventing us from solving, so we need to get rid of the denominator by canceling it. And it doesn't even matter if there's an x down there. This is the denominator. That's what my numerator is being divided by right now. And the denominator really complicates things, so let's cancel it. The opposite of dividing by x plus 4 is to multiply by x plus 4. So I need to do that on both sides. And I'm trying to write it out on the side here. Okay. It's not really in the denominator here. It just looked a little squished there. But those will cancel each other out, which brings just the numerator down. On the right-hand side, I do need to multiply. I'm multiplying to both terms. So I'll get 15x, and 15 times 4 is positive 60. Remember, I'm just distributing here, multiplying to both pieces. Like I mentioned on the very first slide, we have to get this equal to 0 to use our quadratic strategies. So I'm going to move everything over to the left-hand side. I'll get rid of the 15x first. That just cancels over there, which is good. The 60 will come down. And then on the left, we have the x squared. Now we have negative 18x because we're going more negative, and the negative 28 on the end. Now we can just get rid of that 60. We want nothing on the left-hand side. Notice when I'm subtracting the 60, I want to make sure to line it up with its like terms. So I put it right underneath the normal numbers, not with the pieces with the x on it. And that's good. We got everything to cancel on the left. On the right, or sorry, on the left now, I have x squared minus 18x minus 88. Now this is a quadratic equation. We got it equal to 0. So what we're essentially looking for now are the x-intercepts. I did graph this in Desmos. Here it is. And you can see where the x-intercepts are at negative 4 and 22. Those are going to be the solutions. I can show you by factoring as well, because we can think of two numbers that will multiply to get 88, negative 88, and add to get negative 18. And it's going to be related to my solutions that we just saw in Desmos, but the opposite sign. So there's my factored form equation. You can check that, make sure that works by distributing everything out. And now that I have it in factored form, I can see my solutions really clearly. We could see them on the graph too, right? Same solutions. And we do have two solutions this time because we were dealing with a quadratic equation. And just the shape of quadratics, they're able to come back, and because they curve around, they can hit a number twice. Or pass through a number twice. All right, we've got one final example. This one's going to look just a little bit different, where we have two separate fractions on the left, and we just need to combine them into one before we can start using our solving strategies. The problem with the fractions on the left is that they don't have the same denominator. If we think way back to what a fraction is, the numerator tells you how many pieces you have, and the denominator tells you the size of the piece. Like 1/3 is a whole piece, a whole pie cut into 3 equal pieces. Whereas 1/5 would be a whole pie cut into 5 equal pieces. So we can't add these things until we have a common denominator and we're actually measuring the same size piece. 3 and 5 both go into 15. So let's use a common denominator of 15. And 1/3, I can make the denominator 15 if I multiply the whole fraction by 5/5. That will give me a 15 on bottom. And I'm going to multiply the second fraction by 3/3 because that will also give me the 15 on bottom that I wanted. And we've got 1/x on the right. Let me simplify these and show you what I mean. 5/15 is the same as 1/3. I've just scaled it up here. And 3/15 is the same as 1/5. Now I've just written them in different forms so that the denominators are the same and I can actually add them. 5/15 plus 3/15 is 8/15. And that's equal to 1/x. We've got a little bit more solving to do because 1/x is not quite a solution. We don't have x alone yet. X is actually on bottom. We want to get rid of that. We don't want x on bottom. So I'm going to multiply by x to cancel it. And it will go away on the right-hand side, but it will show up on the left. Let me rewrite up here what we've got. So now we have 8x on top over 15, which equals 1. We're getting closer. Now we can get rid of this denominator, the 15 on bottom, by multiplying, because the opposite of dividing by 15 is to multiply by 15. The 8x comes down, and on the right-hand side we have 15. And the very last step will just be to divide out this 8. It's not going to be a nice number solution, but that's okay. We can leave it as a fraction. It's good to check and see if you can reduce it, but 15 and 8 don't have any common factors. So you'll be able to leave it like that. All right, those were our 3 examples for today on solving rational equations. I hope you have a great rest of your day, and thanks for watching.